12 p.m. at night. However, if you put the solar heat resisting roof tile specially designed for this, then the top of the tile would go to 43 degrees centigrade, and the bottom of that, the temperature on the roof would be somewhere around 39 degrees centigrade, and what would be conducted down into the room would be 29 to 36 degrees centigrade. Now anywhere in that temperature, once the ceiling fan is blowing wind, it is comfortable. It doesn't mean it's air conditioned, but it is comfortable, and I think that will helps a lot. We also designed a solar heated and cooled lab in Rawalpindi, and the concept was basically a trombe wall, where trombe wall gets heated, and then because of that heat is retained in the trombe wall, which is almost 23 square meters, for late at night. And this concept is being used all over the world. However, in Pakistan this is the first time it was used, and we used it for heating the entire lab first. And the wall temperatures in summers went as high as 55 degrees centigrade in different months in winters, and then this hot air heated through this wall would be circulated inside through either solar panel or through normal circulation created because of the flow of the air should go up, and the room temperatures were very comfortable, between 19 degrees centigrade to 22 degrees centigrade in winters, January, February and December. Now this was very unique, and because of this experience we actually developed a complete system in Islamabad for use in as high as 12,500 feet in Goma. A hospital was there which was using K2 oil, a kerosene oil, for heating the entire hospital. The combustion was not complete, so soot would be coming out from that. A lot of soot would go, and in the morning you could actually blow out black soot from your throat. So we shifted that onto solar. The entire roof was converted into solar heating panels, and then this front wall was used to store the heat during daytime. And hospital is operational since almost 12 years. It is not using any other source but sun. The best part about that is that although sometimes it gets cold, but people don't shift to the ordinary kerosene because of that smell which gets into the clothes and blankets and everything else. So now it's a very clean hospital, and it was funded by Pakistan Science Foundation and Pakistan Army. During the same time, we developed a very unique special purpose Shamsi Mashq water heating system at Goma, same place, which is almost 12,500 feet high. So in winters the shower was extremely difficult by troops, and shower makes people fresh. So this system was installed by just flat surface, and we placed Shamsi Mashq water heating system there, and water would get heated. Initially we would let it settle down because there was a lot of dust and dirt in the water, but while passing through the Shamsi Mashq it would get settled as well as heated, and then hot water was stored in a hot water tank. And the reason for not taking shower was two: one, the water was cold; two, the bathroom were cold. So we developed a special solar heated hospital. So it became almost a sauna where two persons were supposed to take shower at one time, and every time there used to be 5 to 10 people going into the shower, and sometimes in a day 50 to 60 people would take shower in a day, and that was very freshen up all the people there on the top, and it was very well accepted, and they demanded a lot of those. We also developed solar geysers, and one of the best feeling was once we tested this in Azad Kashmir at a height of somewhere around 7,000 feet to 8,000 feet in a small town, the temperatures or stagnation temperature of from one solar geyser was 92.5 degrees centigrade at 11:30, and it increased to 94.5 degrees centigrade at 12:30 p.m. So that was the efficiency of solar geyser, and the water would actually just boil out because of the sun. We used double pane toughened glass and ordinary steel channelized galvanized sheets with life of 20 years, and stored them in a specially insulated hot water tank. Again, we ensured that only 4 degrees centigrade are lost at night. We've also developed and designed and installed solar street lighting system at Hamdard University. It's operational now, almost 1.5 years, 2 years. There's not a single problem, not a single day in Karachi when light were not on. Not a single maintenance problem so far in 2 years' time. And it automatically goes on and off. It doesn't require too much of cleaning. We've so far cleaned twice in a year, and that was also basically because of the birds which sit down on the top. Otherwise there is no requirement of cleaning it. It requires cleaning, but we've designed it in such a way that it works very well, and just after the rain it gets cleaned, and that's what is very useful for us. We've also developed alternative energy residences at Hamdard University, where students, almost 24 of them, are living on a solar street light, solar fans and lights, and assisted by wind energy also. Simultaneously, we were working, one of my PhD students is working on using the local quartz and melting it to metallurgical grade silicon, so as to we have a raw material in our hand and we know actual cost of the manufacture of solar cells. We already have in Pakistan a technology of growing crystals and fabricating modules from solar cells at 2 different places. So this will be very handy and useful for them. Over a period of almost more than a decade, we've installed almost 3,000 systems in remote areas of Pakistan, and our solar lab lits at night with solar energy. We've lit Rumi Park in Rawalpindi, Presidency Park in Rawalpindi, solar lit Gilgit Park. Entire FCNA gate was lit with solar energy at night. Bharumul village, as I've already informed, is lit on solar energy. So is Allah Bakhsh Dandar in Balochistan. Another very unique thing which I was very proudly claim was identified by me in 1999-2000 was the famous Gharo Keti Bandar wind corridor. Once I started working on this, it was funded partially by Pakistan Council for Appropriate Technology, which is now merged in Pakistan Council for Renewable Energy Technology. The data was being collected by Pakistan Meteorological Department for 26 different stations for 2 to 3 decades at different heights from 6 to 10 meters, and this was subsequently simulated, and then it was mapped for 30 meters for all over Pakistan. So here what we see is a map where from January to April it was slightly lower wind conditions, but yellow is a 4 meter per second wind, and what we see is there was a distinct corridor which is coming up in Sindh. The wind does not penetrate into the Balochistan's coastal area because it's traveling parallel and finds a relief at Karachi, and there are hills all along the coastal area of Balochistan parallel to the coast, and this wind corridor once goes into India, it's being used for power generation. So this was from Gharo to Keti Bandar to Hyderabad. The area was almost